Hello, thank you for joining me. As today I'm going to teach you guys about applied maximum and minimum problems. So let's go. Here is the introduction. Many application problems in calculus involve functions for which you want to find maximum or minimum values. The restrictions stated or implied for such functions will determine the domain for which you must work. The function, together with its domain, will suggest which technique is appropriate to use in determining a maximum or minimum value. And we will use the extreme value theorem, the first derivative test, or the second derivative test to find maximum or minimum values. So, let's fast forward and move to a simple example in the next slide. If 4x plus y equal to 6, find the minimum value of p equal x squared plus y. Let's go step by step. So, we need to find the value of y. For x negative y equal to 6, then we need to solve it. Y equal to 4x negative 6. Then we need to substitute y into the equation of p. So p equal to x squared plus y. We already know y equal to 4x negative 6. So we need to substitute it. Then we will get p equal to x squared plus 4x negative 6. After that, we need to differentiate the equation above. So differentiate x squared, we get 2x. Differentiate 4x, we will get 4. And differentiate negative 6, we will get 0. So dp over dx is 2x plus 4. Next, to find extremum or critical values, dp over dx must equal to 0. So simplify it. 2x plus 4 equal to 0, and we get x equal to negative 2. We need to use the second derivative test to find the maximum or minimum value. To differentiate 2x, we will get 2, and differentiate 4, we will get 0. So the value is 2. 2 is more than 0, and it is a positive. There, so p is minimum. That's right, it's the same just like the question above. Lastly, take the function x squared plus 4x negative 6 and substitute x equal to negative 2. You will get the answer negative 10. So here's the important tip. All maximum and minimum problems must include the second derivative test. So that's all. Thank you.
To solving a maximum and minimum problem, we must know area and volume formula. So here is a table of selected formula for certain shape that are usually asked in question.
Proceed to example 1. A. Express x in terms of y. In order to express x in terms of y, we should find the perimeter. So perimeter is equal to 120 cm. 120 centimeters, I got it from the information given. After that, we will write 130 cm equals to all side length from the shape. So we got all the side of length and it will become like this. 130 equals to all the values that we got just now. After that, we need to simplify. We will get 130 equals to 4x plus 8y plus 10. And then we will put x on the right and it will become like this. To make it easier to see, we can change the position into this. And then we bring 4 to the right and we will divide it by 4. Therefore, the answer is x equals to 30 minus 2y. Next is question 4b. So total area is equal to x plus 5 times 4y plus x times 2y. After simplify, we will get 4xy plus 20y plus 2xy. Then 4xy plus 2xy, we will get 6xy plus 20y. So since x equals to 30 minus 2y, we will substitute x into this area formula. And then we need to expand and we will get 180y minus 12y squared plus 20y. And that's how we got a equals to 200y minus 12y squared. Next is C. Find the maximum area enclosed. The first step is find the derivative of the formula equals to 200y minus 12y squared. So dA over dy equals to 200 minus 24y. And then we moving on to step number 2. Let the derivative equal to 0. dA over dy equal to 0, which is 200 minus 24y equal to 0. And then we're going to keep y on the left and bring 224 to the right. So we get y equals to negative 200 over negative 24. Therefore, y equals to 25 over 3. Next is step number 3, which is second derivative test. Our first derivative is 200 minus 24y, so we need to differentiate one more time. d square a over dy square equals to negative 24. Since negative 24 is smaller than 0, so y equals to 25 over 3 is the maximum value. After that, a max equals to 200y minus 12y squared. Then we will substitute the value of y and then we need to simplify and we will get, so the answer is 2500 over 3.
The diagram shows a closed cylinder with radius r cm and height h cm. A. If its volume is 128,000 cm3, show that the surface area of the cylinder is given by A equal to 2 pi r squared plus 256,000 over r. Volume formula for a cylinder is V equal to pi r square h, so volume equal to 128,000. We need to replace volume by the formula and equal to 128,000. Then we leave h alone on the left and bring pi r squared to the right. Next, we need to substitute h into A. Surface area formula for cylinder is A equal to 2 pi r squared plus 2 pi r h. Here we can replace h value 128,000 over pi r squared. Then we can simplify it. So here, show that the surface area of the cylinder is A equal to 2 pi r squared plus 256,000 over r. Next, B. We need to find the value of r that will give a minimum surface area. Firstly, we need to find a derivative for 2 pi r square plus 256,000 over r. So we get 4 pi r minus 256,000 over r square equal to 0. We need to bring 256,000 over r square to the right, then we bring 4 to the right. So here 256,000 divide 4 pi and we get 20371.83. Lastly, we leave r alone on the left, then we get 27.31 cm as a value of r. To show that r will give a minimum surface area, we need to do second derivative test. The second derivative is 4 pi plus 512,000 over r square. Then we need to replace r value 27.31, so we get 699.04, which is more than 0 or positive value. So the value of r give a minimum surface area.
In conclusion, that is step to solving maximum and minimum problem. First, we need to find the derivative. Second, let the derivative equal to 0 and find the values of the variables. Third, in second derivative test, if second derivative more than 0, it is a minimum value. Then, if second derivative less than 0, it is a maximum value.